In this video, we're going to take a look at an example of a stoichiometry problem involving the ideal gas law. So in this problem, we've got a student that reacts 1.09 grams of calcium with excess hydrobromic acid to produce hydrogen gas and calcium bromide. We want to know what volume of dry hydrogen gas would be collected over water at 28 degrees Celsius and 101.8 kPa. Okay, so let's start with our steps in stoichiometry and work through this problem. Our first step is that we need to write out a balanced chemical equation. So in this problem, we have calcium, which is a solid, is reacting with excess hydrobromic acid, HBr, aqueous, and it's reacting to produce calcium bromide, which is going to be a solid, and hydrogen gas. Okay. Now, we need to balance this because this is not balanced. So we have two H's and two Br's on the product side, so we need a 2 in front of the HBr. This is now our balanced chemical equation. So step 1's done. Now we need to take our given and convert it into moles if needed. So we're given 1.09 grams of calcium. So we can figure out the number of moles of calcium by taking the mass and dividing it by the molar mass. So we have 1.09 grams, and the molar mass of calcium, if we look that up, is 40.08 grams per mole. So the number of moles of calcium that we have is 0.02719. I like to keep about 4 non-zero decimal places just to make sure we don't get any rounding off errors, but that is the moles of calcium. Now, our next step in stoichiometry, any stoichiometry problem, is to use a mole ratio and convert to the number of moles of what we're looking for. So in this problem, we're looking for the amount of hydrogen gas produced. And specifically, we're looking for volume, but before we can find that, we need to find the moles of hydrogen gas. Now, looking at our equation, we have a 1-to-1 ratio of calcium and hydrogen gas. So we could set up our molar ratio, or we could just recognize that it's a 1-to-1 ratio of calcium to hydrogen gas. And so the number of moles of hydrogen gas is also equal to 0.02719 moles. Okay. Now that we have moles of hydrogen gas, we can convert to the units we're looking for. And in this case, we're looking for volume. And because it's a gas, we can use the ideal gas law. So we can use PV equals nRT. And we can isolate for volume. So we can use nRT over P. Now, one thing we do need to note is that this is collected over water. So we do need to take into account that there is some pressure from the water vapor here, and we need to subtract that value. If we were to look up at 28 degrees Celsius, what water vapor pressure is, it is 3.78 kPa. So that means that our pressure is going to be 101.8 kPa minus 3.78. We're using Dalton's law of partial pressures to figure out the pressure just from the hydrogen itself. And so that's going to be 98.02 kPa. Now, we've also been given the temperature of 28 degrees Celsius, and we need to convert that into Kelvin. So that's 301 Kelvin. Okay, so now we can plug these numbers into our equation. We've got 0.02719 moles, 8.31 is our gas constant. We've got our temperature of 301, and our corrected pressure underneath would be 98.02. When we do that calculation, it gives us a volume, and if we round off to the correct number of significant digits, so in this case we need 3, it would give us 0.694 liters, or we could also use decimeters cubed. Or if you want, we could put this into milliliters because it just looks a little bit nicer at 694 milliliters. So 694 milliliters of hydrogen would be collected over water if we were to do this reaction with 1.09 grams of calcium. That's it for this example then. Let's move on to our next task.